Machine pencil cartography. In the pursuit of my dream to expand my journalistic reach naturally into new topics of cartography and surgery theory, this video will introduce concepts of pallynology as they apply to navigational vehicles. This is a meat and potatoes video and will serve to form a solid foundation for future discussions of pallynology. To introduce pallynology, pallynology is a discussion of materials that will often form laminations or films on surfaces. For this reason, it is incredibly reasonable to create a map projection of these surfaces, and this map is known as the planimetric map. Planimetric maps are used for texturing in many 3D modeling and rendering softwares, and are usually called UV maps, but they fall into planimetric mapping as a topographical category. The goal of the planimetric map is to capture exactly what the surface's coatings actually look like. And the planimetric map in this case will be a raster image that is projected onto the surface of the vehicle. I have laid plans to discuss planimetric maps in other videos when discussing geography, so please don't settle into an overly rigid comprehension of what planimetric maps are, because planimetric maps have diverse use cases. In geography, planimetric maps and hypsometric maps often complement each other. Where the planimetric maps capture an object's location in terms of latitude and longitude, the hypsometric maps capture the object's location as it pertains to vertical position. Back to discussing pallynology though. The Krummerlin-Phi scale is used to measure the particle sizes for different materials, where every category is half the size of the previous category. We have boulders, cobblestone, gravel, sand, and finally clay particles. In pallynology, we are talking about particles that often have particle sizes that range from gravel particles, which can be as big as 4 millimeters across, through sand particles that are on average 1 millimeter across, and finally silt and clay particles, which have average diameters of 5/1000ths of a millimeter wide. It is important to know that these particles will form thin films on the surfaces of your equipment, and that pallynology is an actual scientific topic that aims to address these particle effects. As an example of applied pallynology, I would like you to imagine that I am taking you to a motocross track, and I would like you to imagine that we are driving all-terrain vehicles all day long on these very nice motocross tracks. And finally, our all-terrain vehicles are dirty because we have dragged them through some dirt and mud. Well, the scientific field of pallynology can model and represent the fact that this dirt and mud has now become laminated onto our navigational vehicles. And instead of panicking like a reflex agent to tell you to scrub this dirt off, I want to stop first simply to admire how cool this is. There are different patterns which the mud can be applied onto the vehicle, which can be modeled ergonomically, and then we can discuss unique pollen covering attitudes or patterns, which will be called pollen projections. In one specific pollen projection, the mud will come from the track that the vehicle was driving over, and the mud will be kicked up by the tires of the vehicles, and will now cover the area behind each tire with a projection which appears over the fender region of the vehicle. In a second example of a pollen projection, the vehicle operator has encountered a pedestrian bathymetry feature, and the vehicle operator will attempt to skim over the top of this muddy bathymetry feature. The underside of the vehicle will come into contact with the mud, and there will be a unique pollen projection that corresponds to the fact that the vehicle is now wallowing in the mud. And this will be a second pollen projection that is unique and different from our first pollen projection. We may create as many unique pollen projections as we wish, and great creative effort may go into finely tuning these pollen projections as appropriate. Finally, the discussion of pallynology lends itself very nicely to the application of designing equipment maintenance standards, because asking for actions to be performed vaguely and ambiguously often results in poor quality management outcomes, and it is better if we are not ambiguous when describing pallynology management expectations. We may improve our pallynology management outcomes by taking the time out of our days to diligently discuss what our expectations are, so that we may establish objective standards for acceptable pollen management outcomes, which are objective enough to form the basis for fair discipline. Thanks guys, this has been Machine Pencil Cartography, signing out.